Set theory. One of the main things about probability is that, what's today's date? 24th. One of the things about probability is that we were talking yesterday about how we had outcomes and trials and all that stuff, and basically we organize it into sets, okay? So a set is a collection of elements. Okay, so what's an element? Oops, it would help if it wasn't crooked, huh? So what's an element? Remember on matrix, if I had on the matrix, I had like A, B, C, D. The A, B, C, D, those are the elements. So it's the number or item. So it's the number or item, okay? Good, does that make sense? Okay, the universal set, well, wait a minute, let's do an example. Let's do, give me a group of something.
Dogs.
A group of dogs.
Good stuff.
Okay. All right. So we have a lab. Fiddler, what kind of dog do you have? Okay. How do you spell that?
C-H, They're the worst. I do not recommend them.
I had the best dog.
Okay. We'll go with that. I don't know if that's spelled right. Carter, what's the best dog?
English Bulldog. Or
All right.
Bulldog. They're actually the best. So.
Okay. All right. So there's my set. Okay. So a universal set is the set with all possible elements. I'm sorry? With all possible elements. Okay, so let's make this a group of numbers greater than 0, but less than 9. Okay, so that means my universal set would be 1, 2, 3, 4, 5, 6, 7, and 8. Do you agree with that? Okay, what do you think a subset is? What's sub mean?
The like behind it.
Yeah, like if the universal is your top group, it like could be divided into like a subset group. Okay, so a subset is a set with specified elements from the original universal set. Okay, so let's say that we're going to call it A. And A is all the, you want odds or evens? Evens. So A is all the evens. Okay, so that means that A is going to be 2, 4, 6, and 8. Good? Okay, complement is the set with all the elements from the universal, but not in the subset. Okay? So we have the universal, think of it as a bracket. We have the universal, and it's like broken down into the subset and the complement. Subset and complement together then make up the universal. So let's call it B. Or no. Let's do it as how you can write it. So it can be written two ways. You have A and then a little dash, which it means you say A prime. Or you can write it as A with a line over top of it, and then you just say the complement of A. That makes sense? So A prime would be, since it's the evens, we're in the subset, my complement's going to be all my odds, so I would have 1, 3, 5, and 7. Good so far? Yes? You guys remember these at all? A little bit, yes, no? All right, so let's talk about the relationships, okay? Intersection, okay? The intersection is the set containing the elements that two sets have in common. Okay, good so far? All right, so think of intersection as and your symbol is the upside down U. So if we have C is 7 and 8 and D is 7 and 11, what's the intersection of C and D? What's the same in
7.
both? 7. Okay? And if you think about it from a Venn diagram standpoint, okay, then your intersection is going to be what's in the middle. So I have 7 and 8 and then 7 and 11. That's another way to look at it. Make sense? All right. Anybody remember what union is?
I forgot what's spelling.
Huh? A what?
Onion.
Oh.
Does that mean
Well-
like coming together?
Kind of. It's the set that contains all elements in either or both. Okay, so it's almost like, think of it as it's everything. Okay, so you want to think of the union as an or. The symbol is a U. Okay? And so if we have C as 7 and 8 and D as 7 and 11, we want the elements in either. So I have 7, 8, and 11. And you don't have to repeat them. The duplicates. Good so far? All right, we got 2 examples to do. Okay, so everybody with me? Did everybody get that? We have a large bag holding marbles of blue, green, orange, and pink. And we have a small bag with the following colors of red, green, yellow, and orange. What's my universal set going to be?
Blue, green, orange.
Blue, green, orange, pink, red, and yellow. Okay. What are my 2 subsets? Well, large is going to be blue, green, orange, and pink. And my small is red, green, yellow, and orange. Is the small the complement of the large? Do you remember what complement meant? Oops. Oh, it's my notes.
Yeah, they go together.
Complement is all the elements from the universal not in the subset. So if I have one subset of large, that means basically my small is the complement of the large, and vice versa. The large would be the complement of the small. Okay, does that make sense? All right, so let's draw a Venn diagram. So I have my 2 big circles that are really crappy. I have a large and a small. And I have blue. Green is in both. I have orange in both. I have pink. And I have yellow, and I have red. Are you all good on how to set up the Venn diagram? Yep. Okay, what's my intersection?
Green, orange.
And what symbol do I use?
Uh,
Upside down. So L intersection of S is going to be, whoops, bad brackets, green and orange. And my union is going to be what?
everything else.
It's going to be everything, actually, because it could be either, it could be what's included together. So it's basically the universal set. Okay. Alrighty, so next one. I have a universal set of all single-digit positive whole numbers. Oh, that's kind of like what we did. Two subsets are created from the universal. And the set of all evens and the set of all odds would have two subsets. All right, so universal is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Agreed? Okay, my subsets, evens are going to be, where do I put 0?
50. By itself.
Is it even or odds?
I say even.
Is it negative?
No.
I don't know, isn't that the question you guys always argue about, whether 0 is negative?
Oh, yeah.
We're going to say it's even, okay? Because in the number line, it would be in a position of even. Does that make sense?
Yeah.
All right, so 0, 2, 4, 6, and 8, whereas odds would be 1, 3, 5, 7, and 9. So what's the complement of E going to be?
Wouldn't be up.
Yeah, it's going to be your 1, 3, 5, 7, and 9, which makes the complement of your odds your 2, 4, 6, and 8. Do we agree with that? All right, so let me see if I can draw a circle a little better. Do my two Venn diagrams. It's a little better. There's even, there's odds. So 0, 2, 4, 6, and 8. 1, 3, 5, 7, and 9. So what is my intersection of E and O? Say what?
Doesn't seem like there's an intersection.
There isn't. We don't have anything in common, right? So we call that the null set. That makes sense? Okay. And if we have the union, then that is the same as what?
It's the universal set.
The universal set, and we can just write that as universal set. Ooh, we have just 18. Perfect. So we need to get in groups of 2. One, you can flip back and forth if you want, but I'm going to give you a task where, if I can get the right one, you're going to find out the probability of which team's going to win. Okay? You're going to roll a dice, and if you roll a 1, 2, 3, or 4, that means the goal goes to Team Yeti. If you roll a 5 or a 6, it goes to Team Beaver. Okay, and 2 goals are scored in each match. So, for instance, all right, that's a 5. So that means we have the first goal was scored, and the second score was scored. So the final score makes it 1-1. Okay, so it was a tie. Does that make sense? Okay, you're going to do it 36 times and complete this chart and then analyze the reports. Okay, so going back to your memory bank of notes that we did yesterday, okay, for vocabulary. So, this one particular thing that I did, what would that be called? No, the actual rolling of the dice and recording it. What would it be called?
Trial.
That's a trial. There you go. So how many trials are you going to do?
36.
36. Perfect. Okay. Yes, this is an experimental probability because we're actually doing an experiment to come up with it. Okay? Does that make sense? All right. So gather. I picked two people because I figured like one can record and one can roll the dice or vice versa. I don't care. So get with a partner.